It is 1:24 a.m. on March 26, 2024. The waters of the Patapsco River in Baltimore are quiet. Without warning, the MV Dolly goes entirely dark, suffering a complete loss of low-voltage electrical power, instantly killing its propulsion and steering. This is a Neo-Panamax vessel. Fully loaded, it stretches nearly 300 meters long and weighs over 116,000 deadweight tons. Built in 2015, the Dolly represents modern maritime commerce. Container ships of this staggering mass simply did not exist a few decades ago. Drifting without power through a narrow channel, a vessel of this scale instantly becomes an unguided multi-million-ton missile aimed directly at critical infrastructure. Directly in its path sits the Francis Scott Key Bridge. Opened in 1977, this vital regional artery carried roughly 34,000 vehicles every day. Classified as a continuous truss, the interconnected steel framework distributes weight evenly across the span. However, possessing zero structural redundancy, it is fracture critical. Removing a single primary support node guarantees total system failure. The engineering of 1977 produced a rigid, unyielding structure. It was completely defenseless against the kinetic energy generated by the modern megaships that would eventually share its waterways. At 1:27 a.m., the ship's pilots issue a frantic mayday call. This gives local police exactly 90 seconds to halt traffic at both approaches to the bridge. But an operating crew of 6 maintenance workers is on break in their vehicles, filling potholes on the center span. They have no warning of what is approaching in the dark. At 1:28 a.m., the 300-meter ship strikes the bridge's southwest pier while traveling at roughly 5 knots. This animated equation breaks down the physics of the crash. Decelerating 116,000 tons of mass in a matter of seconds generates an impact force exceeding 100 meganewtons. The loss of the southwest pier initiates a progressive collapse. The failing section violently drags down the central and northern spans, plunging them into the river in under 30 seconds. 6 men, Alejandro, Thorlian, Jose, Carlos, Miguel, and Maynor, lose their lives in the water below. The sheer physical inevitability of the crash turned a localized mechanical failure into a rapid mass casualty disaster. To find out exactly how the ship lost control, the National Transportation Safety Board extracted the Dolly's voyage data recorder. The forensic analysis revealed a critical detail. The Dolly had suffered 2 separate, undocumented power blackouts while in port, just 10 hours before departure. Investigators traced the root cause of these failures to a specific electrical control center deep within the ship, Terminal Block 381. This schematic demonstrates the exact physical failure. An improperly labeled cable, known as Signal Wire 1, vibrated loose from its socket clamp. This tripped a critical circuit breaker that killed all steering and propulsion. Because the Key Bridge was built in an era with different standards, its grandfathered dolphin and fender protection systems were completely bypassed, leaving it exposed to a drifting ship of the Dolly's immense size. A single unfastened wire, vibrating loose in the dark, destroyed one of the nation's most vital bridges. Clearing the federal channel required an unprecedented heavy-lift salvage operation. The 116,000-ton ship lay securely pinned under thousands of tons of mangled steel wreckage. The force of the collapse physically impaled the wreckage deep into the channel floor, trapping the vessel and severely complicating the cleanup efforts. The resulting 11-week port closure sent economic shockwaves through the region, draining an estimated $15 million a day from the local economy. The estimated cost to rebuild the bridge is staggering, up to $5.2 billion, with a completion timeline stretching out to 2030. This localized devastation proves that the financial cost of failing to upgrade infrastructure vastly outweighs the cost of maintaining it. This vulnerability extends well beyond Baltimore. Across the United States, over 4,000 bridges currently face the risk of ship strikes. This map highlights an alarming data point. 8 specific U.S. bridges share the Key Bridge's exact fracture-critical profile and vertical clearance. This includes heavily utilized structures like the George Washington Bridge, as well as the Verrazano-Narrows Bridge and the Chesapeake Bay Bridge. The Key Bridge collapse was an inevitability, brought on by decades of infrastructural stagnation matching up against modern maritime commerce. Until America systematically upgrades its bridge defenses to match the staggering scale of today's megaships, the next collapse is simply a matter of time.